So the one thing I wanted to mention as we get talking into the Pacific Arctic, I mean, we touched upon how it's just been really cold. Um, you know, one of the coldest winters up here in recent memory. That has one positive side to it. It has allowed the sea ice to really grow.
Okay.
In fact, the sea ice is actually now it has a. I just saw some recent data has the highest extent for this time of year that we haven't had in recent years. So the sea ice is actually further extended in a bigger area. So it's gone a little further south through the Bering Strait into the Bering Sea. So think back to what we discussed about ice edge productivity. This is going to be helpful for that.
So I'm looking at the two graphics you sent me. Well, it's like one. It's from NASA, right? The current state of sea ice cover. The sea ice cover is one of the key components of the polar climate system, and then it has this graphic, and that's what you're saying. It's around March 1st. The red line, which is 2020, is slightly above 2012 or 2007. Both they're all gray. Both of the recent. Is that the graph you're looking at or referring to?
Hang on. If you look at the red line, it goes right to March 1st. Yeah, that's kind of okay. That's kind of in the middle, but it's more than the 10-year average from '09 to 18, and it's still less than the 79 to 88 10-year average. So the first three lines are 10-year averages. Well, actually, first four lines are 10-year averages, and so it's more than the last 10 years, but not as great as it had been, say, 40 years ago, is what that is showing.
Okay, and then because the Arctic has been cooler than average this winter,
Has
this
allowed for that, for the ice extent in the area to be more so than it has been for the past 10 years, basically.
okay, well that makes sense. But will it drop, you think, if it gets to be a really hot summer?
That's difficult to say. It all depends what the AO does as far as the
Okay.
indices go. That's difficult to extrapolate that out at the moment. I would caution against trying to do so. But now, if you scroll down a little further, which just goes that Arctic ice extent, not for the 10-year averages, but year by year, starting
Yeah, it
with
breaks it down even further from the 2010s.
you have 2010, 2011, etc. Then go 2020 in red. That's the one I had in mind. You can see that that has the greatest
Oh,
extent since. That's on pace to
2012.
having the greatest extent on a year by year basis. The others were 10-year averages. This is a year by year basis.
This is really interesting. I like the colors. It really shows you like what's been going on.
Yeah. So that to me is also very telling of how much cooler this winter has been.
And you can see that even the little micro graph underneath
Right.
the big graph. Yeah, that's kind of interesting too. It
Yes.
shows the decade.
Yeah. So that's some really interesting data there to look at.
Yeah, we're about close to 2012, but we'll see how
Pretty
it
much on track
fares
there. Yeah, pretty much on track.
in August, September. It seems that's where it starts to dip. Well, that's when it dipped.
Right.
Starts to dip coming up, but
Because that's the oceanic summer.
okay.
Remember, there's always the lag um, between you know what the air does and what the water temperatures do.
I see. And the
So
first graphic is it's interesting because it's deceiving, I guess, at the micro scale, right? Looking at individual years versus the whole
versus,
decades.
versus a 10-year average. Yeah.
Yes, 10-year average. So over 2010s. Well, yeah. Okay,
See,
it got
we lots of times, if you try to do a year by year comparison, the analysis gets gets muddled. You can't really tease out signals. So oftentimes, a a tool that is used is to do a 10-year average, a 20-year average, a 30, even a 40-year average, and then compare, a current situation to that average 10, 20, 30, 40 years, whatever it may be. And that is probably a better handle on any trends. This is significantly different from that 20-year average, to say. Oftentimes in
gotcha.
meteorology, they do a 30-year average. Oftentimes, don't know why they settle on that, but they do. That's what climatologists tend to. So, for example, you hear a lot of 1981 to 2010. That's a 30-year thing
Okay.
when you include the endpoints, 81 to 10. So you'll see that a lot. So now when 2020 ends, now we're going to see a 1991 to 2020 30-year average.
Oh, we're shifting.
Then they're going to use that analysis to then compare what comes after 2020.
That's very interesting. Yeah, we're moving along really
Right?
in the data.
That's what's often meant by a moving average, is that, let's say I want to know the average for, a 5-year period. Okay, so you calculate the average, say whatever that parameter is in a year. Then you take 5 years and you take the average of that. So let's say you have year 1, 2, 3, 4, 5. Okay, that's 5 year. At the end of year 5, you get a 5-year average. Then you go 2, 3, 4, 5, 6. At the end of year 6, you get the 5-year average for those previous 5 years, and you keep going like that. So 3, 4, 5, 6, 7 give you another 5-year average. That's called a running average.
Okay.
And then you can plot those, and then you can see some certain trends. And basically, if there was no trend and you start plotting those values, you get a flat line, zero slope.
Okay. Hold on. The Arctic ice extent. Um, so overall, you're saying that it's better to look at bigger. You take
When
this.
when
I'm
when climate
losing
when
the
climatologists
idea.
talk about, you know warmer than usual, whatever,
Hmm.
they're comparing to a 30 or 40, 50-year trend.
Okay.
That's what they're doing. So, for example, even though we wouldn't know it up here in Alaska and the Yukon, January was the warmest 2020. February was
Right.
also the warmest 2020. You wouldn't know it up
Oh
here,
wow.
but February is also the warmest the warmest
Okay.
February ever. And
That's not good.
they say that because they compare to what's happened before.
Hmm.
And then when they say it's warmer, I mean, that would mean it has to be statistically significant. If it's within errors, then you just say, okay, that's just within errors. It's not statistically significant. So we can't say, oh, this is the warmest ever. So when you hear things like warmest ever or least amount of ice ever, that's from a statistical aspect.
Okay, and
You can
then
apply statistical significance to it.
as the shift moves, the the 80s records aren't as important anymore in a way.
It's
I
not
mean,
so much
like,
that they're important, it's just that they want to then say, because let's put it this way, if we're doing 81 to 2010, and then we're in 2020, say we're in 2028, and we're still trying to compare back to that 30-year average, that might be misleading. But if
okay.
we think of it sort of as an update, so what's happening is like we're creating new normals, if you will. Well, the situation's
Yeah,
getting
I was
warmer.
trying to say the mean is shifting as well.
That's right. And if it still continues to shift up, that's even more compelling for the changes that are happening.
That makes
But
sense.
let's just say, I'm just going to throw a ballpark. Let's just say the average global temperature for 81 to 2010 was 10 degrees C. I'm just going to throw that
Okay.
out there. I don't know what the actual numbers are offhand. Okay, and then we say, okay, so that's 81 to 10. 2012, it was 14 degrees C. Ooh. that's warmer. Is it significantly different? You do the analysis, probably yes. So now we come to 91 to 2020, and let's say, okay, now the global average temperature was 11.5 C. Right? So now if you have a temperature that's, say, 12 C, is that going to be statistically significant compared to that 30-year trend? Probably not. But if it's 14 or 15, probably yes.
Okay.
That's just to try and give a general aspect of how to look at this. I said those are
I
not hard
gotcha.
numbers, but I'm just trying to use numbers to illustrate.
So go ahead.
It's like the same thing. You talk about errors. Okay, when you have errors, when you put confidence intervals around the value, the mean is 100, whatever it might be, and then the error, the 95% confidence interval is plus or minus 10. Okay, so that means from 90 to 110, the true actual mean, the its true value, 95 times out of 100 is between 90 and 110. If you have if your confidence interval takes it from 80 to 120, that's where the true value is, well, that's a bigger range. That means there's more error, there's more uncertainty in whatever it is you calculated. So in a lot of ways, by moving the average, we're trying to reduce the uncertainty.
Okay, that makes sense. So wait, when does the average change next year?
At the end of this year, when because the end of a decade, and then 2021 starts a new decade of running averages. That's kind of by convention.
So that's good to know, considering going forward.
Yeah, the convention is they go from the year ending in 1 to the next one ending in 0, and that's a 10-year thing.
Okay. And that's part of the scientific community, like
That's
the
kind of
way
what
you
we do.
guys frame. Okay.
I mean,
History is a
not
little different.
sometimes they look at 50 years, 60, 70, 100 years. Sometimes they'll do that just to do the exercise, just to see even. But the other thing is also is that when you start doing like a 10, 20, or 30 year, the smaller the interval, you can actually tease out more signals as well. So you can still have a long enough period to get an overall average, but it's short enough to tease out signals.
And this is why data is so important to use and reference, because it really tells the story.
Exactly.
And it's just like, it's almost like a book, but you're reading like numbers and graphs, and it tells a story. So
It does. And it's when we look at the numbers, yeah, we can tell what's going on, and we can then see the trends, and we can then say, this is happening because, and then whatever the cause may be, or whatever the situation is. But running trends is something that's often done. It's also part of what's called time series analyses. And oftentimes, if you have jagged edges, there's a process called Fourier smoothing, which is just a way to smooth the data to make the analysis a little easier and for any trends to be noticed.
okay.
And for that matter, any outliers to be noticed.
So going back to, oh, go ahead.
I would say I just get these random thoughts that pop in it, but
Oh, go
but
ahead. That's why
but
we're here.
that's another advantage of using like the 30-year running average, because we can then more readily identify an outlier.
Right. And yeah, so there's different benefits of looking at the larger scale versus a micro scale, and vice versa. But
Exactly.
the
Exactly.
larger to see an overall trend. There
Exactly.
was more, but it's Antarctica. Did you want to cover that? I mean, this is kind of interesting for me. But
Let's see
like,
what.
is it
Oh, I mean, when they did yeah, I saw the graph. Yeah, let's see, Antarctic ice extent. Oh, by the way, if you look at the two graphs, you see how they're like mirror images of each other,
Yeah.
like top to bottom. That's
Mm-hmm.
because of how their seasons are. Where it's high for the Arctic, it's low for Antarctic and vice versa because of, southern versus northern hemisphere.
I see.
So when you look at the Antarctic ice extent, we see that for 2020, again, as compared to, running averages for previous decades, that's the lowest ice extent yet.
Interesting. That is very interesting.
That's what that
Considering
is
what's
telling
going on in
us.
the north.
Yeah, exactly. So you see
Plus
that for
that, oh,
the
sorry, go
area
ahead.
and the extent, it's the lowest. And if you scroll down, it shows the southern hemisphere. Yeah, you can see. You look at the that yellow line that's kind of squiggled around the continent of Antarctica.
Mm-hmm.
Okay, that shows the maximum extent, and then the red line's the minimum extent.
Ooh.
And that the maximum was in '08, the minimum was in 2017. So 2020 isn't over yet, but 2020 may
Uh,
be less than 2017.
so 2016 was our hottest year on record.
Right.
Um, I'm going to make a bold prediction and say 2020 is going to surpass 2016. I know it's early in the year, but I don't know. Things are heating up. If it's a hot January, I'll just a hot February.
Yeah.
This isn't good. But it's what's supposed to happen, right? So we can't be shocked, but it is shocking in the moment. This
Absolutely. I
shows.
mean, yeah, it's so
I don't know.
I mean,
This is crazy.
Antarctica is just very low ice extent.
Which plays into what we talked about last week.
If you scroll down further in the graph to show comparison year by year, it's
Ooh,
kind of
okay.
in the
I love this stuff.
it's not when you do year by year, it's not the absolute least amount, but when you compare to decade by decade, it is. So again, it shows you the difference of teasing out from a running average versus just year by year comparisons. Because year by year
Okay.
comparisons are not very helpful. But when you do a long term average, then it becomes a more helpful analytical tool.
So right now, 2020 is kind of average in terms of 2010s, or
I would
well,
put it in the about the 70 percentile of warmness, if you will,
okay,
because that kind of looks like it's about the 70th percentile. Just eyeball on the graph, which means it's
okay,
more than 50%.
okay. It's very interesting. Completely different than the Arctic,
Yeah.
in a way. Yeah. Is it orange or is it yellow?
So, I mean, I think with that pretty much is telling us what is going on with as far as the sea ice at both the ends of the planet.
Both poles, yes.
Yeah, at the two poles there, and looking at that article, the
Right.
causing dramatic changes in the Pacific Arctic. Okay, basically, no, it starts off with nowhere is safe from the climate crisis. Some regions suffering more than others. The Pacific edge of the Arctic Ocean is one of those regions changing in big, scary ways. And then they talk about papers cited, published in Nature Climate Change, that they underwent a sudden and dramatic shift from 2017 to 2019. And they fear these effects could be irreversible and could be
Right.
happening on the same thing on the Atlantic side. And what they're talking, it says usually Arctic ice melts throughout the year's warm months and refreezes throughout the colder ones. Duh. Okay. These seasonal cycles in sea ice and water temperatures drive the area's ecosystems. And they talk about, this is stuff we've already discussed, by the way. And
Right. Last week.
right. And this, again, ties into when I talk about the ice edge productivity. And they're just basically explaining this in layman's term, but that's basically what this article is telling us. Is
Just
that
everything's being disrupted,
yeah,
ecosystems. the local indigenous populations versus even commercial fishing, I'm guessing as well. Um, yeah, so
Oh,
oh,
Huntington, Henry Huntington. Well, he's got to be one of the Huntingtons. Huntington's a big family, Athabascan family here in Alaska. Um,
oh, okay. Yeah, Henry Huntington.
yeah, some areas became
Oh,
entirely sea ice free. Henry Huntington studies lead research and consultant climate issues in Alaska, found the lack of sea ice in the northern Bering and Chukchi in wintertime mind boggling. Until this cold really settled in and allowed the ice to regrow, we discuss, on Christine's podcast, how little ice has been. I've been discussing that on my show, how little ice there is, but it happened. The loss of ice and warmer than average temperatures triggered a number of troubling changes throughout the food web. Warm water forced plankton and fish deeper into the water column in search of cooler temperatures, and therefore that puts them out of the range that birds can reach them. The birds can only dive down so far, and if the fish are deeper in the water column, the birds are not going to get them. They're going to starve. This affects the marine mammals, seals, right? They eat the small animals, hang around the edges of sea ice. It goes back to the sea edge thing.
mm-hmm.
So as the ice melted more rapidly, science observes spotted seal pups were thinner and smaller than normal.
It's not good.
2018, the summer, scientists found 280 seal carcasses. In the community of Utqiagvik, which used to be called Barrow, there was a formal name change in 2016. So it's now officially called Utqiagvik, not the Barrow anymore. But
Okay.
had a very poor whale hunt. They allow the natives to harvest whales, specifically, like, for example, a bowhead whale. They're allowed to take a bowhead whale because of cultural and other,
Mm-hmm.
and food subsistence. And you've heard me discuss before how the phytoplankton community has changed over in the Bering Sea from diatoms to coccoliths.
Yes.
So th- this is more of it. This is more stuff going on here. Sea ice reflects sunlight, whereas open water absorbs sunlight. Okay, the reflection of sunlight is called albedo. Albedo reflects the energy back into space. It cools the surface down. Open water absorbs the sunlight. Eventually, that latent heat energy is given off. It keeps the area warmer. Taking sea ice away will result in warmer water, which leads to less sea ice, but also warmer air temperatures. So there's a feedback loop. And then
Okay.
you have the issue
Yeah.
of the thawing permafrost, melting land ice. Without the sea ice, there's no protection against the coast. So now you have more storms, and the storms beat the crap out of the coast. And then you get whole chunks of real estate falling into the ocean. All sorts of stuff going on. So
And
that's
it's all compounding, it
it is.
seems.
It absolutely is. What I'll probably do is when we make this video here, I think I'll include a link to that article in the description box.
Okay.
Anyway, anything else you want to say about that?
Just very interesting. Obviously, more to come. Um, the difference between, I guess I'm reflecting, the difference between Antarctica and the Arctic from the graphs was very interesting to go over. Really telling a story again about what's going on in the southern section. I hope to hear more from this from you, Jim Massa. So,
It's and the thing is, as you said earlier, it's just like this is just really kind of running away now.
mm-hmm.
It's
The
just
tipping
becoming.
point you said, and the feedback loops.
Oh yeah, it's really kicked in big time, and it's a bit scary actually.
Yeah, like you could maybe pose the question, like, what is the future in like 10 years? I mean, if it's changing that fast, you know,
Right?
I mean, what will 2030 look like? What will the graph look like in 10 years as we're here in 2020?
I mean, for the IPCC to come out and say we have to do something by 2030, it's like, I mean, IPCC is so, oh God, I mean, it's really more of a political body, and they just really underestimate and downplay everything. So for them to basically saying we got to do something by 2030, it's like even they're pressing the panic button, which means
Exactly.
it's a lot worse.
I know, and
Eh,
that's yeah. I mean, the feeling's numbness now because it's just like we're at this tipping point, or maybe we surpassed it, and it's like
I think we have surpassed it, to be
I
my assessment of it.
I'm in agreement with you.
I say that based on the data.
Correct. It just keeps getting progressively worse in the sense that we are warming up each
Hmm.
decade in a way.